Hi and welcome back. Today we're going to look at section 2.5, which is on average rate of change. So again, we're going to look at the overview, some definitions and concepts, and then we will work some problems. All right, so many quantities met in everyday life change with time. This is especially true in the science field. A chemist may be interested in the rate at which a substance dissolves in water. A biologist may want to know how the bacteria in a culture is changing with time. So this lesson will introduce the concept of average rate of change in a function, f of x, with respect to x, as the independent variable changes from x1 to x2. Okay, so a rate of change. You've actually done this quite a bit in your algebra careers. You may not have called it average rate of change, but most of you know what this is. So what we're going to do today is determine the average rate of change from an explicitly defined function. And then we're going to determine the average rate of change of a function from a graph. Okay, so we're going to do the graphs, we're going to look at functions. So typically that's what we do in here, is be able to look at it in both forms. All right, so let's look at our functions or concepts and definitions for today. So if you remember, the Greek capital letter delta, okay, looks like a triangle, is used in calculus to indicate change. So the change in x can be written as delta x, and the change in y can be written as delta y. So we use that a lot, and anytime you see delta with a variable, that means figure out the change. And the change in something is just the difference. Okay? So number 3, for a function y equals f of x, as the values of x change from x1 to x2, the corresponding y values will change from y1 to y2. Or remember that y is another way to write f of x. So we could say it changes from f of x1 to f of x2. This is the same thing as y, right? All right, so number 4 says if y equals f of x, then the ratio, the change in y divided by the change in x, is equal to y2 minus y1 over x2 minus x1. Or you can use f of x sub 2 minus f of x sub 1 in place of these. Okay, that is called the average rate of change of y with respect to x as x changes from x1 to x2. So this right here should look very familiar to you. Okay, you've done that since pre-algebra days. That is the formula for the slope. Okay, the slope of a line, m. And m was always the change in y over the change in x. That's how we found the slope. So to say that you're finding the average rate of change is very similar, is exactly the same as finding the slope. But this time, it may not be a line. We use just a slope to find the change in a straight line. But we can actually use this to help us find the rate of change in any kind of function. It doesn't have to be a straight line. So we're changing it up a bit, calling it the average rate of change, but that is what you're going to do. Change in y, subtract the y's, over the change in x, subtract the x's. So nothing too terribly difficult today, you just need to understand what you're being asked. All right, and then number 5 says, okay, here's where some of the new part comes in. If you let h equal x2 minus x1, okay, so notice the denominator is x2 minus x1, so we're going to let that equal h, okay? So you need to remember in your head that h is always the change in x, okay? So it says if we let the h equal x2 minus x1 in the average rate of change formula, then this formula that we had over here evolves to this. So instead of doing just slope, y2 minus y1 over x2 minus x1, we are going to do f of x plus h minus f of x over h. Okay, we learned this in the last couple of sections ago that that's called a difference quotient, right? We already worked with that a little bit. So now we're seeing that we can use this for an average rate of change. So sometimes you'll be using this formula, sometimes you'll be using this formula. All right, so let's look at a graph first, and then we'll look at some functions. So the graph is pretty straightforward because always on a graph you can find the x and the y values. So number 1 says, use the graph of f of x to find the average rate of change from x1 which is negative 5, to x2, which is negative 2. All right, so here's negative 5. So I have that ordered pair. So negative 5, 6. And we want to go to where x2 is negative 1. That's over here. Sorry, where x2 is negative 2, which is this point. Okay, negative 2, negative 3. So here's x1, here was x2, which means these are the y values that go with it. So this would be y1 and y2, right? All right, so to find the average rate of change, we're going to use the formula. Okay, we got y2 minus y1 over x2 minus x1. So we're just going to work that out. So we've got negative 3 minus 6 for the y's over negative 2 minus negative 5 for the x's. Okay, so in the numerator you have negative 9. Negative 3 minus 6 is negative 9. In the denominator you have negative 2 plus 5, so that would give you a positive 3. So that equals negative 3. So there is the average rate of change from this point to this point. Now remember, slopes, if we're looking at the line from here to here, right? Remember, lines that come down should have a negative slope, and that does it is negative. Okay, so average rate of change is just a way to find the slope. But this is average because we just found the distance or the slope from here to here. Okay, that's not the same change anywhere else on the graph. Okay, if I found the rate of change from here to here, that would be a little bit different. So that's why it says the word average. Okay, it's the average rate of change of 2 points on any graph. All right, now for problems 2 through 4, we're going to find the average rate of change from x as x changes from x1 to x2. So the only difference with these is that they're not giving you the y values. Okay, on a graph, you can see the ordered pair, so you know x and y without doing any work. On these problems where you're given a function, they're going to give you x, but they didn't give you y. So for each of these, the two x values they give you, 1.5, so there's x1. So we have to find y1, and then they gave you x2, which is 3, so we need to find y2. Okay? So unlike the first one, where we already knew these 4 numbers, we have to find these numbers. But they gave you a function, so all we have to do is put the x values in here and solve for y. So I'm going to do f of 1.5, which would be 5 times 1.5 plus 3. And then I'm going to plug this in for y, x, so I'm going to do f of 3, 5 times 3 plus 3. Okay? So it's very easy to find the y values in a function. You're just going to plug in the x value you're given and find y. All right, so f of 1.5, okay? So 5 times 1.5 plus 3, you can put that in your calculator, okay? This is going to be 7.5 plus 3, so that's 10.5. And then 5 times 3, 15 plus 3 is 18. All right, so now you have your values for y. So now we're going to do exactly what we did up here, find the average rate of change, because I have my values now. Okay, so the average rate of change, okay, y2 minus y1, x2 minus x1. So we're going to do 18 minus 10.5 over 3 minus 1.5. Make sure you keep your numbers in the right order. That's why I like to label, so that way you make sure that you're doing them in the right order. Can't switch things around. All right, so 18 minus 10.5 is 7.5. 3 minus 1.5, I don't know why I put 1.5 there. Okay, that was just writing too many ones. Sorry about that, 1.5. I think I said 1.5, but I wrote 1.15. All right, so 3 minus 1.5 is 1.5. All right. So you can do this in your calculator, 7.5 divided by 1.5, and you end up with 5. So there is the average rate of change in this function just from those 2 points. Not the whole function, but just from x1 to x2. All right, same thing with number 3. We're given a function, we're given 2 x values. Okay, so again, x1 is 1, we need to find y, and x2 is 3, we need to find its y. So here's x1, we need y1. Here's x2, you're missing y2. So how do you find the y values? Plug in your x values into the function and solve. So we're going to do f of 1. Okay, so we're going to put 1 in here to find the y value for 1. So negative 2 over 2 times 1 minus 1. That gives you negative 2 over 2 minus 1 is 1. So negative 2. Okay, so there's your y value for 1. And then you're going to do the same thing for 3. Find f of 3 in the function. Negative 2 over 2 times 3 minus 1. That gives you negative 2 over 6 minus 1 is 5. So negative 2/5. Okay? All right. So now you can find the average rate of change between these 2 points. So what is delta y over delta x? Again, y2 minus y1 over x2 minus x1. So we get negative 2/5 minus negative 2 over 3 minus 1. Be careful with your signs on these. Okay. So that gives you negative 2/5 plus 2 over 3 minus 1. Okay. Negative 2/5 plus 2. 2 is the same thing as 10/5, so that gives you 8/5 in the top. And 3 minus 2 in the bottom is 2. And you guys can do these on your calculator if you need to. I got 8/5, just to remind you, this is the same thing as 10 over 5. Gotta have a common denominator. 10 over 5 is 2. So then I have negative 2 plus 10, which gave me the 8 in the top. All right, and then 8/5 divided by 2, that's 8/10. And you can reduce that down to 4/5. Okay? All right. So we got one more function where we're going to do a radical function. Okay? They're all the same though, as long as you just take your time, get the right y values, and then do this work carefully, watch your signs, you should be fine. All right, so let's look at number 4. All right, now we got a radical, but it's the same thing. We want to find the average rate of change as we go from 4 to 4.44. So I need to know the y value of both of those. All right? So they gave me x1, I need y1. They gave you x2, we need y2. So we're going to plug these two numbers into the function and work it out. So first we'll do f of 4. That's the square root of 4 minus 3, which is the square root of 1, which is 1. So there's my y value for the first point. And now I'm going to do f of 4.44, which is the square root of 4.44 minus 3. That is the square root of 1.44, which actually works out, right? 12 is 144, so we just move the decimal. So 1.2 is the square root of 1.44. All right, so you have your ordered pairs. So now you can find the average rate of change. So delta y divided by delta x. So y2 minus y1, so 1.2 minus 1 over x2 minus x1, 4.44 minus 4. Okay, so 1.2 minus 1 is 0.2. 4.44 minus 4 is 0.44. And if you do that in your calculator, I want to just make sure, because you got to be careful on Hawks. Repeating decimals, or when decimals don't end, sometimes Hawks doesn't like your answer. So 0.2 divided by 0.44. So let's look at that. 0.2 divided by 0.44. gives you 0.4545454545. Keeps going forever and ever and ever. Sometimes if you try to put that in Hawks, it will mark it wrong because it wants an exact answer. Okay, so first off, let me write that decimal. So we know that we can write 0.454545 like that, right? But if it wants an exact answer, remember that all repeating decimals can be changed to fractions. So you're going to hit your math button and then number 1 and then enter. And it'll change that to a fraction for you. So 5/11ths would probably be the way you want to enter that. That is an exact answer. Okay. This is fine if it's on paper. It's fine if Hawks takes it, but just in case, just wanted to show you how to go from there to there. Okay. All right. Now, the last problem is going to be finding the average rate of change, but we're going to do it using the difference quotient. So we're still doing what we just did, but remember that we're changing now, and instead of using the formula y2 minus y1 over x2 minus x1, we changed the x2 minus x1 to h in the bottom, and the top y values became this, right? So first and foremost, we're going to find the difference quotient, and then we're going to use it for parts 1, 2, 3, and 4 on part B over here, okay? So first let's find the difference quotient. We've already done this, so this will be good practice, okay? So remember what this first part says, okay? Says replace all the x's in your problem with x plus h. So that would be 2x plus h squared minus x plus h minus 3. And make sure you put those in parentheses. So instead of x, you're going to put x plus h, and instead of that x, you're going to put x plus h. So that's the first part, that in brackets, just so we keep it separate. And then minus sign. Then you write the function down in parentheses. So 2x squared minus x minus 3. Remember, f of x is what they gave you. So just write it down, but make sure you subtract it, because that means you got to change all the signs, right? All right, all of that over h. So that is the difference quotient. Now we just have to simplify. I've done this enough with you to square x plus h, so I'm just going to write that. X plus h squared, remember, is x squared plus 2xh plus h squared. Remember, you got to FOIL that out. Okay, we've done that plenty of times. All right, then minus, I want to just go ahead and keep the rest the way it is for a minute. Now you can do more than one step here, but I'm just doing one thing at a time, so some of you need to kind of see the steps. So always the first thing you do is the powers. Now we're going to distribute. Okay, now we're going to get rid of these parentheses. So we're going to distribute over here, this first parentheses, multiply everything by 2. So 2x squared plus 4xh plus 2h squared. Then we're going to distribute, remember this is like a -1, so that's -1 times x, -1 times h, that gives you minus x minus h. You have that minus 3 there. And then same thing here, this minus sign is like a 1 here, so you got to multiply each of these terms by -1, which will basically just change those signs. Okay, still all of this is over h. All right, now we're going to do some canceling. What do we have that can cancel? I got a positive 2x squared and a negative 2x squared. I have a negative x and a positive x, and I have a -3 and a positive 3. Those all go to 0. So I am left with 4xh plus 2h squared minus h all over h. And then remember to factor out one h in the top, because you need to cancel the h in the bottom. So take one h out of each of those terms. So that's going to leave you 4x plus 2h minus 1 over h. And then you can cancel that h with the 1 in the bottom. So the difference quotient is 4x plus 2h minus 1. So that is your difference quotient, and we're going to use that in the rest of these problems coming up. Okay, you have to be able to work that difference quotient, so please make sure you're practicing that. All right, now let's go to part B. Part B says use the difference quotient, this, to find the average rate of change from x1 to x2. All right, so remember, h is x2 minus x1. Okay, x is where we're starting from, 2. So in this problem, h would be 2.5 minus 2, which is 0.5. Okay, and x is our first number that because we're starting here going to here. Okay, if you look at the next page, our starting value is always 2. So that's x. And then h would be the difference between those. Okay? All right, so for this one, we're going to do 4x plus 2h minus 1. So there's the difference quotient. X is always 2 in these problems. Okay, the original value. And then h is the difference between those. So we're going to do 4 times 2 plus 2 times 0.5 minus 1. Okay? You can do that in your calculator however you want to do those. So that would be 8 plus 2 times 1/2 is 1 minus 1 gives you 8. So there's the average rate of change using the difference quotient. Once you have the difference quotient, I think it's much easier than doing the slope formula all the time. But the original part where you have to get that takes a while. But it's good to use this if you're using the same value over and over again. And since we are using 2, it's good to just keep plugging it into that formula. Okay? All right, so now if you look at part 2, I'll leave that here for a minute. So when you look at part 2, we're going from 2 to 2.1. So x is still 2. Okay, we're still our starting point. But now h is going to be 2.1 minus 2, or 0.1. Okay, so now our h value changed because we didn't go as far. Okay, so we're still going to use the difference quotient, and we're going to plug in these values. So 4 times 2 plus 2 times 0.1 minus 1. Okay, so that's 8 plus 0.2 minus 1, which gives you 7.2. Okay, so there's that difference quotient, or average rate of change. Okay, so notice the distance between x was a half here. Now the distance between the x's is just 0.1. So we're kind of looking at limits here. If you think about it, we're getting closer and closer. Right? That's a limit problem. So now look at our h value in part 3. Now we're going from 2 to 2.01, an even smaller distance, right? So x is still 2, and this time h is going to be 2.01 minus 2, or 0.01. So we're still going to take that difference quotient, find that new value. So 4 times 2 plus 2 times 0.01 minus 1. Okay, so 8 plus 0.02 minus 1, that gives you 7.02. Okay. All right, and lastly, even a smaller difference. We're going from 2 to just 2.001. So again, x is still your starting value. H is the difference. So that's 0.001. So one more time, we're going to find the difference quotient, which is that average rate of change. So 4 times 2 plus 2 times 0.001 minus 1. That gives you 8 plus 0.002 minus 1, which is 7.002. See a pattern there. All right, so just kind of to make sure this is making sense to you. We're done. That's how that problem works. But I want you to just take a look at what we did. Okay. So we went, make this a little smaller so you can see it all, I hope. Well, that's as small as I can go. All right. So we started from 2 and went to 2.5. So that was a distance let's say like that. The rate of change between those two x values was 8. But then we just went from 2 to 2.1. So then we went from here. So that rate of change was 7.2. Then we went to 2.01, which is here, right? That little rate of change was 7.02. And then the last thing we went to was 2.001, really close. So the difference, so you can see the distance between our x's was getting closer and closer to almost nothing, right? I'm very close to the same point. That one was 7.002. So remember the limit as x approaches 2 from that right side, what is it approaching? It's approaching 7. So we will learn, okay, that we can find the actual limit at 2. We don't need the distances if we know the limit. So these difference quotient problems are helping us figure out what the limit is without having to do a lot of this work. Okay, so we'll keep working on that as these sections move on. All right, so hopefully that makes sense to you. You've got some homework to work on, so please try to get that done as soon as possible and let me know if you need any help.